Hello friends, this is Sanjay. In this video, we will discuss about the concept of child as a problem solver and a scientific investigator. This is part of the Karnataka TET CDP syllabus for paper 1 and paper 2. In this series, I am covering only those topics which are important from your exam point of view. In this video, we'll start with an understanding of what are problems. Then we'll look at the various types of problems. What is problem-based learning? We'll look at the steps in problem solving strategies, the Gestalt approach, the scientific method, and Graham Wallas' creative problem solving technique. We'll also understand what are the classroom strategies that we can use to develop problem solving skills. What is the importance of problem solving, child as a problem solver, and child as a scientific investigator? We'll also talk about the traits that we need to encourage in children to develop their problem solving skills. And we'll end this video with some sample questions from previous question papers. So let's get started. Since this video revolves around the topic of problem solving, we should first clearly understand what are these problems. Now, the term problem is something that we normally associate with some difficulty that we are facing in life, or we think of problems in the context of maths problems or science problems. But problems are much more than that. Problem can be any situation where we have to take a decision or we have to take some action. For example, if I have to wake up at 5 a.m. tomorrow morning, the problem here is how do I wake up? And to solve that problem, I will use an alarm clock. If I have to have breakfast tomorrow, should I make the breakfast or order the breakfast? So here I have to take a decision and also complete some actions. So that is also a problem. Tomorrow morning, if I'm trying to go to office and my car does not start, then that is a difficulty. So that is a problem that I need to solve. And if I have to go do some shopping, then I have to take some decisions. What do I buy? Where do I buy? And I have to take some actions on the basis of my decisions. Watching a movie again is a problem because I have to decide which movie do I watch and where do I watch it? Do I go to the theater or should I just watch it on Netflix? So problems are things which we face everywhere and every day of our life. Problems can be classified into ill-structured or unstructured problems and well-structured or structured problems. Now, ill-structured problems means they are not clearly defined, whereas well-structured problems or structured problems are clearly defined. For example, if tomorrow I go to my mechanic and I tell him, my car is making a kar sound sometimes. Now, I'm not giving him any useful information to work with. Is the sound coming from the front of the car, from the back of the car? When does this sound come? I'm not giving him too much of information other than giving him a problem that the car is making some kar noise. So this is an ill-structured or an unstructured problem. Whereas if I go to the mechanic and I tell him that the left front wheel is making a noise when I turn. So I'm telling him where the noise is coming from, when does this noise come. So this is a clearly defined or a well-structured or a structured problem. Now let us talk about the concept of problem-based learning. In the traditional learning approach, it is the teacher or the syllabus who tell the students what they need to know. For example, the teacher or the syllabus may tell the students that you need to know how to calculate the area of this triangle and how to calculate the area of this pentagon. And then the students will understand the formulae, they will memorize it, and then they will solve some examples to understand how to use it. So this is the traditional approach. So this is being driven by the teacher or by the syllabus. So this is teacher-centric or subject-centric. In the problem-based learning, the students are assigned a problem. For example, the teacher might assign a problem, calculate the area of this star. Now, the students have to figure out what they need to know and how they can solve this problem. So after some analysis, the students may realize that this star actually has 5 triangles and it has one pentagon in the middle. So if they use the formula for calculating the area of a triangle and calculate the area of these 5 triangles and use the formula for calculating the area of a pentagon and calculate the area of this pentagon in the middle, and if they add up all of these, then they will get the area of this star. So in both approaches, students are learning the same thing. But in the traditional approach, it is the teacher or the subject which is driving the learning. Whereas in the problem-based learning approach, it is the students who are driving the learning, which means that this is a learner-centric approach. And because the students are actively constructing the knowledge here, it is a constructivist approach as well. So the students are learning by working in groups and they are solving an open-ended problem because there might be more than one way of calculating the area of this star. So they are finding out the way that actually works for them. Right? So they are finding out the method that they can understand. Now it is the problem that is driving the motivation and the learning. Right? It is not the teacher who's driving the motivation and the learning here. It is the problem that they need to solve. So what can students learn through this problem-based learning approach? First of all, they are working in teams. So they will learn how to work in teams. Next, there will be some leaders and some followers in this team. So they will learn leadership skills as well. Because they have to communicate with each other and with the teacher, they will learn oral and written communication skills. When they start working on this project or this problem, they will understand what they know, what they don't know, right? So there is a self-awareness that is created. When they are analyzing this problem, they will practice the skills of analysis and critical thinking as well. Because they have to understand and explain the concepts to the other students and the teacher as well, they learn how to explain concepts. And they are applying some theories, right, or formulas to solve some real-world examples. And because they are doing a lot of research to find all these formulas, then their researching ability will also increase. That is how children can learn through this problem-based learning approach. Let me give you a small assignment. Go to Google and search for problem-solving steps or problem-solving models. You will find a number of colorful illustrations with different types of models. Now, if you look at all of these, they might have 3 steps, 5 steps, 8 steps, 12 steps. But if you go into the depth of each of these models or the details of each of these models, you'll see that all of them are using a very similar kind of an approach to problem solving. They might have used different kind of terminology, or they might have increased the number of steps. In some models, 2 or 3 steps are combined to decrease the number of steps. But beyond the number of steps and this terminology, they are all very, very similar in nature. There is a basic approach and there are some fundamental steps that are there in all these problem-solving models. First, we have to identify the problem. I'm not able to make any calls from my mobile. And then I have to analyze the problem. That is, it can be a network issue, it can be a phone issue, or it can be a SIM card issue as well. Then I have to hypothesize some solutions. If it is a network issue, then if I go outside, I might get a better signal. If it is a phone issue, then I can restart the phone and see if it works. If it is a SIM issue, then I need to reinsert the SIM. So I will evaluate these solutions and figure out which one of them is the easiest one. Because logically, I will start with the easiest solution first. Restarting the phone is the easiest solution. So I will restart the phone. That is executing the selected solution. And then I will evaluate the outcome. After restarting, am I able to make any calls? If yes, my problem is solved. If no, then I will build on that solution or build on the previous hypothesis, and now I know that restarting the phone did not work. So which means that it is not a phone issue. It might be a network issue or it might be a SIM issue. So I will go back to the analysis mode and try another hypothesis or try another solution. So this is the basic approach for problem solving. Next, let us look at some of the important and common problem-solving strategies that can be taught to children in the classroom. The first is using a rule or a formula. That is, if the problem is not unique, somebody has solved it earlier, or if it is a standard problem, then there might be a rule or a formula that the children can use to solve such problems. Or they can use a trial and error method. This is also called the guess and check method. Or in some cases, if the problem has a lot of data, then making a table or a list can help them analyze the data better and arrive at a solution for the problem. Some cases, they might need to make a diagram, a chart, or a graph or a model to understand the problem in the first place. Sometimes you may need to act out the problem. For example, if I lose my keys, then I try to walk the same path again. That is, if I started from A and walked till B and I lost my keys somewhere in the middle, I try to retrace my steps so that I'm acting out the problem and see if I can find my keys through that way. Sometimes you may need to look at the problem and see if there is a pattern, because if you are able to identify the pattern, then you can solve the problem. Sometimes there might be a lot of information in a problem or a question, and you need to eliminate the irrelevant information that is not important and focus only on the relevant information so that you can solve the problem. Or you might need to break down the problem into small parts. When you break it down, you'll be able to identify what do you need to do to fix the problem? Where is the issue? Or sometimes you may need to sit back and use some logic and reasoning to arrive at a solution. Sometimes if the problem is very complex, then solving a simpler problem will clarify the approach and then you can solve the more complex problem. Sometimes you may need to work backwards. If you know the answer, then you can work backwards and find the solution. So these are some of the common and important problem solving strategies that are taught in the classroom. Let me now talk about the Gestalt approach. In the Gestalt approach, we can solve problems by using reproductive thinking or productive thinking. Reproductive thinking means we are reproducing a previous solution. That is, we are reusing a previous experience to solve a new problem. For example, when I'm in Jaipur and the house gets hot, then I fix an AC and the house becomes cool. When I move to Hyderabad and in summer when the house gets hot, so the easiest way to solve this problem is to use reproductive thinking. I can reuse the same solution. I can reuse my previous experience. So all I need to do is fix an AC and the house will become cool. Whereas in productive thinking, I can look at the problem using a new viewpoint. I can use a new approach by restructuring the problem. If I realize that in Hyderabad, right, my house is on the topmost floor, which means that the reason for the house becoming hot in summer might be because the roof or the ceiling is becoming hot. So instead of using reproductive thinking and fixing an AC, what I do is I get the roof coated with white colored paint or this summer cool coating. So if the roof does not become hot, then the room remains cool. So that way I'm solving a similar problem by using a new approach, by restructuring the problem and looking at it from a new angle. So that is productive thinking. In the Gestalt approach, the reproductive thinking is also called as the algorithmic approach because we will be following a specific series of steps and there will be a predictable outcome. For example, in Jaipur, when it became hot, I used a specific series of steps. I called a shop, they sent an AC, the AC got fixed and the room became cool. Similarly, in Hyderabad, I can follow the same series of steps. I can call a shop, they will send an AC, it will get fixed and the AC will definitely cool the room. So that is a predictable outcome. So that is an algorithmic approach. Whereas in the productive thinking, I was trying to look at the problem in a new way. I was trying to use a new approach. So this is called heuristic approach. Here I'm taking an educated guess. I'm not just randomly thinking about painting the roof. There is some research that I've done and I'm not going to be using any random color. I want to specifically use white color. So if by getting the roof painted with white color paint or with this summer cool coating, if it becomes cool, then that will become a guide for future situations that I can reuse the same solution in future situations as well. So that is the difference between algorithmic approach and heuristic approach. In some previous question papers, you'll find questions asking you that in the scientific method of problem solving, which is the first step, which is the last step, or they will ask you which is the correct sequence or order of the steps. So we should know about this scientific method of problem solving as well. Now, this is very similar to what we have already discussed, such as the first step is always ask a question. For example, if you have a torch that is not working, then obviously your question will be, why is the torch not working? And then you will do some background research. That is, there might be some reasons as to why torches do not work. The batteries might be depleted, the bulb might be fused, or the switch might be defective. So you will do some research and find out the main reasons as to why this problem can occur. And then you will construct a hypothesis. So your hypothesis may be that the batteries need to be changed because the batteries might be old and may be depleted. And then you will test the hypothesis. That is, you will change the batteries. And then you need to see whether the hypothesis work or it did not work. So does the torch work now after changing the batteries? If it works, then you can draw a conclusion that the problem was with the batteries and you can communicate it to anybody who needs to know about it. So you can communicate the results. If changing the batteries did not fix the problem, the torch is still not working. So the answer is no. Did the hypothesis work? It did not work. which means that you will construct a new hypothesis. For example, you might now think that the bulb might be defective, so the bulb needs to be changed. So you are going back to testing the new hypothesis, and that's how the flow works. So this is the scientific method of problem solving. Let us now look at Graham Wallas' creative problem solving approach. Graham Wallas was a British social psychologist and an educationalist. He was also the co-founder of the prestigious London School of Economics. If you remember, in the development chapter, we discussed about the nature versus nurture theory. So Graham Wallas was a proponent or a supporter of the nurture theory. That is, nurture is more important than nature in the cognitive development or the development of a person. And he was also one of the first to propose a relatively complete model of the creative process, that is the creative problem solving approach. This is a very interesting approach, so let us briefly understand what this is all about. In Graham Wallas' creative problem solving approach, there are 5 distinct steps: preparation, incubation, illumination, verification, and elaboration. During the preparation phase, I try to understand more about the problem. I'm trying to see what is the kind of solution that I'm looking for, what is the data that I have to solve the problem, what kind of resources do I have, and is there any quick or easy fix for the problem. During the preparation phase, this is all the groundwork that I'm doing. However, if it is a very complex problem, I might not be able to solve it during the preparation phase. So I might get frustrated after a while. I might get tired. So then I say, let me get up and go for a tea or go for a walk. Or if it is late in the evening, I might think, let me go and sleep and I will come back and try to solve the problem tomorrow. During the incubation phase, I'm not actually trying to solve the problem. I'm trying to give my brain some rest. I'm either taking a walk or drinking tea or sleeping. Right? But subconsciously, my brain is still trying to solve the problem. And that is the incubation phase. Sometimes during the incubation phase or the next day when I come back to office, I might suddenly get an idea as to how to solve the problem. And that is the illumination phase. See, it's like a bulb that suddenly glows. This is the way that I can solve the problem. Right? Now I have an idea. So I need to verify it. Is this the right approach? Does it make sense? So I test it out. If it works, then I will elaborate it. Elaboration means I will document it, I will implement it. So these are the 5 distinct stages in Graham Wallas' creative problem solving approach. Let us now talk about some of the strategies for teaching problem solving techniques in the classroom. As we discussed, there are many different kinds of problem solving models, some with 4 steps, 5 steps, 8 steps, 12 steps, and the terminology that is used in these models may be different, but they all use the same kind of basic fundamental approach. So it doesn't matter which model we choose to teach in the classroom. We can use any specific problem solving method. Next, we have to teach that particular model or method in a specific context. That is, we have to give students a relevant and a simple and easy to understand example so that they can understand how this method can be used in real life. So teach with a specific context that they can relate to in their real life, in their day-to-day life. And we have to help students understand the problem. We have to teach them the technique of analyzing a problem, how to gather the data, and how to use some critical thinking. Next, some students may be fast, some students will be slow. So you have to give enough time for all the students to be able to understand and complete that particular problem. Next, we have to ask some questions and we can also make some suggestions so that we are encouraging them to think. We are helping them to look at that particular problem from different angles. And by asking questions and making suggestions, we are stimulating their thought. Then, whenever the children make any errors, we have to link those errors to misconceptions. That is it a mistake or a misunderstanding? Is it a calculation error or an understanding error? So, link the errors to misconceptions. And after we have completed the teaching, we have to reinforce the learning with some revision or some practice. So, these are some of the strategies for teaching problem-solving techniques in the classroom. Let us now look at why is problem solving so important in our day-to-day life. By teaching problem solving techniques to children, we are definitely helping them in improving their academic performance. And because we face problems every day, everywhere in our life, by teaching problem solving techniques and methods, we are also helping improve their social skills. And you can see that if children are able to solve problems, then they have less to worry about, so they are more happier. And because now they know that they can solve any kind of problem, they can approach any kind of problem methodically, so their self-confidence also improves. And because of their performance, their self-confidence, they are also more likely to get some recognitions. And in general, by teaching these problem-solving techniques and methods, we are making the children life-ready. By training children as problem solvers, we are helping them to be able to anticipate problems in life. That is, we are training them that they will face some problems in life, and problems are part and parcel of our day-to-day life. And we are making them able to deal with unexpected situations and difficulties, which all of us face in our real life. And we are helping them take rational decisions whenever they are faced with a problem or an unexpected situation. Then they are able to analyze that particular situation or problem and take a decision based on some logic and reasoning, and not just take some rash decision. And by training them as problem solvers, we are also helping them develop their leadership skills. And how can we train children to become better scientific investigators? Well, the problem solving methods and approaches are same whether it is a social problem, it is a financial problem, or a scientific problem. So we have already discussed the important steps in training children in problem solving skills. Now, as far as scientific investigators is concerned, we have to specifically focus on the reasoning and the logical skills of children. And plus, we also have to help them develop their foundational skills for STEM learning. STEM means science, technology, engineering, and mathematics. So, by helping them develop their foundational skills, their basic knowledge, we are helping them become better scientific investigators. So, these are some of the ways in which we can help children develop their problem solving skills. With a perspective of making children into better problem solvers, so what are the essential traits that need to be encouraged? What are the kinds of behaviors that the teacher needs to inculcate in these students in the classroom? Well, the first one is to develop language skills, because the first step to solving any problem is to understand the problem, to structure the problem, and this is where language skills are very, very important. Children are naturally very curious about everything around them, so we should encourage that curiosity. And we should also help them develop their scientific thought. That is, whenever they look at something out of curiosity, we should help them use a scientific viewpoint to look at that particular situation, to analyze it. So that is scientific thought. Sometimes children put in a lot of effort into something. A child might practice very diligently for a competition, but the child might not win the competition. In any case, the effort and the process should also be rewarded, and not just the results. And children naturally get distracted by a lot of things. So we should also help develop their focus and persistence, that is concentration. And we should encourage children's imagination. And sometimes children may look at things from a different point of view. So we should encourage divergent views as well. And we should allow children to question status quo. If there is a common assumption that a particular problem can be solved in a specific way, and if children are questioning, why can't we solve it in a different way? That is questioning status quo. So children should be allowed to question this status quo. And we should also provide scaffolding or support to develop their knowledge wherever required. So these are some of the steps that the teacher should take in the classroom. Now let us solve some sample questions from previous question papers. The first question is, which of the following is the first step in the scientific method of problem solving? In this video, we discussed about the steps in the scientific method. Now, the first step is asking a question, because that's when we become aware of the problem. So, problem awareness is the first step. And formation of hypothesis is constructing a hypothesis. Verification of hypothesis is testing the hypothesis. And collection of relevant information is doing background research. So here, problem awareness is asking a question, which is the first step in the scientific method of problem solving. If a teacher wants her students to acquire problem solving skills, the student should be engaged in activities that involve which of the following. Now here we have been given a few activities. So we have to identify which of these activities are used most frequently in solving problems, and which of these activities will help students develop their problem solving skills. The first one is recall, memorization, and comprehension. These are all essential learning techniques, but these will not help students in developing their problem solving skills. Next, structured worksheets containing multiple choice questions. So children are just solving the questions on that particular worksheet. So this is definitely not helping in their problem solving skills. Next, drill and practice. This is a reinforcement technique where children are repeating something. They are either understanding it better or memorizing it. So this is not an essential problem solving skill. Inquiring, that is asking questions, reasoning and decision making. These are very essential for solving problems. Therefore, if children are engaged in activities which require these skills, then they will automatically develop their problem solving skills as well. So the answer is option 4. Which of the following statements about children are correct? Children are passive recipients of knowledge. This is an incorrect statement because children will not just sit in the classroom in one place and just listen to a lecture and absorb the knowledge. Children have to be actively participating in the teaching learning process. Only then they will understand and they will learn. So children are passive recipients. This is incorrect. So which means that any option which has 1 in it will be incorrect. So option 2, option 3 and option 4 can be eliminated. So we are left with option 1, which is the correct answer. So children are problem solvers. Yes. Children are scientific investigators. This is also correct. And children are active explorers of the environment. That is, they are very curious and they keep exploring the area that surrounds them. So that is also correct. So 2, 3 and 4 are correct statements. Which of the following does not deter problem solving? That is, which of these behaviors does not stop us from becoming better problem solvers? Now, fixation. Fixation means an obsession. If we are fixated about something, we are not able to look at that thing or that person from a different angle. So this definitely stops us from becoming better problem solvers. Entrenchment. Entrenchment means an idea that is very deep rooted in our mind. It is an idea that we just can't get rid of. If we can't get rid of that idea, then it looks like fixation, it looks like an obsession. And because of this entrenchment, we are not able to look at that situation or person from a different angle. And then we cannot solve the problem properly. So entrenchment deters or inhibits problem solving. Next, mental sets. Mental sets means I have made a connection between some two things, and unless I break that connection, I'm not able to look at the problem from a different perspective. So this mental sets also sometimes stop us from solving problems. For example, if I have formed a mental set that to travel from Mumbai to Delhi, I need to travel by flight. So then one day I have to travel, I look at the flight tickets and there are no tickets available. So that means that I'm stuck. I'm not able to think of anything else because the mental set is very strong and it is stopping me from looking at any other options. If I'm able to break that mental set, then I can explore other options. I can go by bus, I can go by train, I can drive. So mental sets sometimes stop us from looking at new solutions to an old problem. And finally, insight. An insight means we are having a better understanding into the problem or a better understanding into the situation. So insight definitely helps us in solving problems. So this does not deter us from solving problems. How can we enable students to think independently and become effective learners? The last option is present information in an organized manner and make it easier to recall. So we are talking about memorization here, and this will not help students become independent thinkers and effective learners. So this is not a correct answer. Then give information in small units or chunks. This is an effective teaching methodology, but this will not help them become independent thinkers or effective learners. Next, offer rewards for each success achieved by the students. So it is not just the success which should be rewarded. Even the failures, even the effort and even the process should be rewarded. Therefore, offering rewards only for success is not a good idea. Therefore, this cannot be the correct answer. Next, teaching students how to monitor their own learning. If students are monitoring their own learning, then they are working independently. They are thinking independently. And if they are monitoring their own learning, they know what they have learned, what they still need to learn. Are they learning at the right speed? So they are becoming effective learners. Therefore, option 1 is the best answer here. And with that, we come to the end of this video. If you have any questions or feedback, please put them in the comment section below. And I will see you again very soon in the next part of this video series. Till then, take care, stay safe.